In this question, we have to identify I naught. Here, I naught is nothing but current flowing through 6 kilo ohm resistance. How much current passing through this path? Using, here I am using KCL. Okay. Now, before going to apply KCL, we have to identify number of junctions. First step is number of junctions. Observe this circuit carefully. Here, the bottom portion, for example, let it be this is the one. This point, and this point, this point. Otherwise, you can convert this imaginary circuit into practical circuit. Then you can easily identify how many number of junctions, how many number of nodes are there easily. Okay, let me convert this into practical circuit. There is one 4 kilo ohm resistance like this. Okay, this one. For one terminal of 4 kilo ohm resistance, there is a 6 kilo ohm resistance connected 16 kilo ohm resistance. Okay, like this. At the same point here, there is one more resistance connected like this. That is nothing but a 12 kilo ohm resistance. This is a 12 kilo ohm resistance. For the second terminal of 12 kilo ohm resistance, there is one more resistance connected like this. That is nothing but 4 kilo ohm resistance. Like this. Okay. The second terminal of 4 kilo ohm resistance is connected to 2 kilo ohm resistance, and 2 kilo ohm resistance second terminal is connected to one voltage source like this. Okay. And the same terminal of second terminal of 4 kilo ohm resistance connected to 6 kilo ohm resistance like this. Okay. On the bottom of each element connected to same point like this. All second terminal of bottom terminal connected to like this. Okay, this is a practical circuit. So by observing this practical circuit, this point considered as a junction, and this is also a junction because there are three paths. Three elements are connected at this junction. Okay, let it be. This is our one more junction, and this is also a junction. Okay, so in this given circuit, there are three junctions: junction one, junction two, and junction three. Okay, this is the first step. If you if you want to know where are the nodes, so this is the node one where 12 ohms and 4 ohms are connected together. So this point is called as node, and the point connected between 2 kilo ohm resistance and 12 ohms source. This is also called as node. Okay, there are three junctions and two nodes here. Similar to that, I apply like this for imaginary circuit. This is a junction. This is a junction, and one more junction here, and one more junction here. J1, J2, J3. So this is the first step. And second step, indicate voltages for each junction. Okay. For junction 1, I am assuming V1. This is V2, and this is V3. Like this. V1. Let it be. This is V1. This is V2, and this is V3. And the reference voltage is here, bottom junction V3, and the voltage of reference voltage is V3 equals to 0. So this is equals to 0. And third step is we have to apply KCL for each junction except reference. Okay, except reference, we have to apply KCL for each junction. First of all, apply KCL at junction 1. Okay, this is a junction 1, and to apply KCL at junction 1, we need to indicate correct directions at this point. Okay, at this junction, I am assuming current path in this path. Let it be I1, and this is I2, and this is I3. There are three paths at junction 1. The correct directions for at junction 1 is I1, I2, I3. All are outgoing currents only. I am assuming all are outgoing currents. You can assume any directions. Here I am assuming all are outgoing currents. Now apply KCL at junction. Apply KCL at junction 1. Okay, according to KCL, sum of incoming currents equals to sum of outgoing currents. There is no incoming current at junction 1. Since there is no incoming current at junction 1, it is equals to 0. Okay, and the outgoing currents are I1 plus I2 plus I3. This is incoming current and this is outgoing current. Sum of outgoing currents equals to sum of incoming currents. So simply we can write it as I1 plus I2 plus I3 is equals to 0. Let it be equation number 1. Okay. Now we have to identify or we have to get a expression for I1, I2 and I3. Okay. Uh, Let us find the expression for I1, I2 and I3. At junction 1, at junction 1, expression for I1. I1 is nothing but I1 is a current flowing from V1 to here V1 to V1 to V2 through 12 kilo ohms resistance and 4 kilo ohms resistance. Just draw that path as it is, that path only. This is 12 kilo ohm resistance, 4 kilo ohm resistance. This is V1 and this is V3. So here reference voltage V3 is equals to 0 and current direction is, my assumed current direction is like this. This is I1. Okay. Now apply KVL for this loop. Minus V1 plus 12,000 I1 plus 4,000 I1 plus V3. Ending point I am assuming as positive. Then V3 is equals to 0. Then the reference voltage is equals to 0. After simplifying this equation, 16,000 I1 is equals to V1. Then I1 is equals to V1 by 16,000. Let it be equation number 2. Now expression for I2. How to get an expression for I2? Where is I2? Here I2 starting from V1 to V2 and flowing through 16 kilo ohm resistance. Just to draw that path. This is 16 kilo ohm resistance. This is V1 and this is V2. Sorry, V3. V3 value is equals to 0. Here the current direction is from top to bottom. It is top to bottom I2. Now apply KVL for this. Minus V1 plus 16,000 I1 is plus V3 is equals to 0. Then I1 is equals to V1 by 16,000. This is expression for I2. Sorry, this is I2. Right. Let it be equation number 3. Okay. Again, expression for I3. At junction 1, there are three currents. Those are I1, I1, I2, and I3. Okay. The starting and ending point of I3 is it starts from V1 and end at junction 2. Okay. Just draw that path as it is through 4 kilo ohms only. This is V1 and this is V2. Okay. This is 4 kilo ohm resistance. And the current direction is like left to right. This is I3. Now apply KVL minus V1 plus 4,000 I3 plus this is the ending point. Okay, this is starting point and ending point. Ending point is nothing but V2 is equals to 0 according to KVL. But here V2 is not a reference. In this circuit, there are two junctions V1 and V2. Yeah, and the reference junction is V3. Here reference junction is V3. Since then this equation can be modified as I3 is equals to V1 minus V2 divided by 4000. This is the fourth equation. Here we applied KCL at junction 1 only. After applying KCL at junction 1, we got I1 expression, I2 expression, and I3 expression. Now substitute these three equations in equation 1. Okay. I am substituting those three equations in equation 1. What is equation 1? I1 plus I2 plus I3 is equals to 0. Sorry, once again. Here, okay, right. V1 is nothing but I1 is nothing but V1 by 16,000 plus I2 is nothing but V1 by 16,000, I think. Yes, 16,000 plus I3 is nothing but V1 minus V2 divided by 4,000 is equals to 0. As rearranging this equation like this, V1 by 1 by 16 plus 1 by 16 plus 1 by 4 minus V2 by 4 is equals to 0. After solving this equation, 16 inverse plus 4 inverse. So this is equals to 0.375 V1 minus 0.25 V2 is equals to 0. So this is equation number 5. This is equation number 5. Again, so here we applied KCL at junction 1 only. According to the 4 steps, we have to apply KCL at each junction except reference voltage. Now we have to apply KCL at junction 2 also. Okay, where junction 2? At junction 2, I am assuming current directions like this. Again, all are outgoing currents. I am assuming this is outgoing current, this is also outgoing current, and this is also outgoing current. To avoid confusion, here at junction 1, I already assumed that I1, I2, I3. Okay, you can also assume I1, I2, I3 at junction 2 also. Uh, to avoid confusions, to get a clear idea of currents, here I am assuming different currents. Like after 3, this is related by I4, I5, I6. Otherwise, you can also assume IA, IB, IC also. Okay. Here also at junction 2, I am assuming 3 currents are outgoing currents only. Okay. Now apply KCL at junction 2. Now apply KCL at junction. So at junction 2, all are outgoing currents since I4, I5 plus I6 equals to 0. Now let it be equation number 6. Now we have to identify expression for I4, I5, I6. That I4 expression. What is I4 here? No, forget about I1, I2, I3. Don't consider I1, I2, I3. Just uh, keep it in mind. We are applying KCL at junction 2 only. At junction 2, we have only I4, I5, I6 currents only. Okay. Here I4 flowing from E2 to V2 to V3. So according to my current direction, okay, through 4 kilo ohm resistance. Just to redraw that circuit. This is a 4 kilo ohm resistance. So this is V2 and this is V1. And my current direction according to the circuit, current direction is like this from V2 to V1. This is I. Now apply KVL. This is the starting point and this is end point. So minus V2 plus 4000 I4 plus V2 V1 is equals to 0. Okay, here there is no reference junction voltage. Reference junction is nothing but V3 only. Okay, here only V1, V2. These are not reference voltages. After simplifying this expression, I got I4 is equals to V2 minus V1 by 4000. Okay, this is the equation number 7. Okay, again, expression for I3, I5, sorry, I5. What is I5 here? It is current flowing from junction V2 to V3 through 2 kilo ohm resistance and 12 also source. Just read the circuit as it is. V1, V2, one resistor and one more voltage source, and polarities are upper terminal is positive, negative, lower terminal is positive. This is V3. This is V3. This is V1. Here the resistance value is 2 kilo resistance. Here the resistance value is 2 kilo ohm resistance and voltage source is 12 volts source. Okay. And my assumed current direction is top to bottom. Here it is top to bottom. This is I. Now apply KVL. This is the starting point. This is end point. Here V3 reference and it equals to 0. Now apply KVL. Minus V1 plus 2000 I5. So here I am traveling from negative to positive. That's why I am considering minus 12. Okay. Plus V3 is equals to 0. Here the reference voltage V3 is equals to 0. Then after simplifying this expression, I5 is equals to V1 plus 12 divided by 2000. Let it be equation number 8. Okay. And one more expression for I6. Here I6 is nothing but current flowing from V2 to V3 through 6 kilo ohm resistance. Just read that circuit as it is. 6 kilo ohm resistance and this is V2 and this is V3. This is 6 kilo ohm resistance. And my current direction, my assumed current direction is like this. This is my current direction I6. Now apply KVL minus V2 plus 6000 I6 plus V3 is equals to 0. Here reference voltage V3 is equals to 0. Then I6 is equals to V2 by 6000. Okay, this is ninth equation. Okay, ninth equation. Now substitute these three equations I4, I5, I6 equations in equation number 6. After substituting those three equations, we will get V2 minus V1 by 4000 plus V1 plus, sorry, V2, I think it is V2, sorry. This is V2, V2, V2. V2 plus 12 divided by 2000 plus V2 by 6000 is equals to 0. Okay, after simplifying, minus V1 by 4 plus V2 into 1 by 4 plus 1 by 2 plus 1 by 6 is equals to minus 12 by 2. So this is nothing but minus 0.25 V1 plus 4 inverse plus 2 inverse plus 6 inverse is nothing but 0.9166 V2 is equals to minus 6. Let it be, this is equation number 10. After applying KCL at junction 1 and junction 2, we got two equations. Because since the given circuit has two junctions, we will get two equations with two unknown variables like this. Okay, fifth equation and 10th equation. Two equations with two unknown variables. Those are nothing but V1 and V2. Now solve these two equations using your calculator. Well, let me check the values of V1 and V2. 0.375 minus 0.25 0 minus 0.25 0.9166 minus 6. Okay. After solving these two equations, I got V1 is equals to minus 5.33 volts. V2 is minus 8 volts. Okay, V1 and V2 are the junction voltages. But a question is, we have to identify what is the value of I naught in the given circuit. In the given circuit, I naught is nothing but current flowing through 6 kilo ohm resistance only. As per circuit diagram, current flowing through 6 kilo ohm is nothing but I naught. But according to my current directions, the current flowing through 6 ohm kilo ohm resistance is I6 only. This I6 is nothing but I naught only. These two are equal. So I naught current flowing through 6 ohm resistance, I naught is nothing but I6. But I6 is nothing but V2 by 6000. Am I right? Okay. After solving these two equations, we got V2 equals to minus 8. Minus 8 divided by 6000. The value of 8 by 6000 is nothing but minus 1.33 milliamps. So this is the I naught expression. Okay.